We're going to look at one last topic, normal probability plots, and also known as normal quantile plots. Sometimes you'll see software called QQ plots, abbreviated, and what this stands for is quantile plots, and the different names really pertain to how the calculation is done, but they're all trying to do the same thing. And what are we trying to do here? So I have a numerical data obtained from some population. How do I know that it comes from a distribution that is normal? Now, the normal probability plot is a graph that hopes to answer this question. Okay, so what is that this graph does? The idea behind it is as follows. If I told you I'm going to flip a fair coin, and I flipped it 20 times, and I ask you how many heads would you expect to get, I think you would say, well, if I'm tossing this 20 times, I'm expecting for a fair coin to get 10. What happens if you were to then toss it for 30? How many would you be expecting to get as far as, like, say, heads? I think you would say 15. Okay, and so what if I created a graph of the following? What I expected and what I got. Okay, now let's say that what you expect is exactly what you got. So if you tossed it 10 times, you were expecting 5, but what if that's exactly what you got? And if you were, I should say, actually, let me pick that back a little bit. Sorry. Got a little ahead of, I tossed it, I said 10 times, and I was expecting to get 5, and what you got was 5. If you tossed it 20 times, sorry, and this one I'm getting confused. I'm confusing myself. I was expecting to get 10, and then you got exactly 10. And if I continued, you notice that it would make a perfectly straight line. Okay, so in other words, if what you expect and what you get are exactly the same, you get a nice straight line. However, that's not what you're going to do. Sometimes if I was doing this with real data, what would happen is this. Maybe I was expecting 5, but what I got was 4, so it would be a little less than what I expected. If I tossed it, I was expecting 10, I might have got 12, I would have got something like that, and so on. So what I actually get and what I expect are a little off, but if I continue down the road like this, keep going, I would sort of expect that the graph would follow kind of a linear pattern. And that's what's going to happen here. What we're going to graph is the following. And there's a couple ways that this could be done. I'm going to just do it this way because that's the way the software we're going to do works. But the data goes on one side, and then what's called the expected z. Like, what is the z-score that I would be expecting from one particular data set? And the idea is this: how close are we to a straight line? The closer we are to a straight line, the more evidence we have that our data comes from a normal distribution. So I'm going to look at this situation. It says in 1798, English scientist Henry Cavendish measured the density of the Earth by careful work with torsion balance. The variable recorded was the density of the Earth as a multiple of density of water. So this is the data, a distribution, a histogram of the distribution of the data the person got. And you can tell right here that this is definitely looks symmetric to me, or fairly so. Now, does it look like a normal model? Well, I mean, it sort of has a symmetry, whether I can put a bell-shaped curve on this, or I don't know, or normal. It's not clear to me. So the idea here is that this normal probability plot will help us do this. So on this axis, notice, is the data right here. If you look closely, it matches to these values. Okay. So the data is on this axis. Sometimes instead of this, the software might put, instead of the data, it might take all the data values and turn them into z-scores. If it does that, then you'll have z, but the z of the data. But here, this is not, again, the z of the data, is what I expect to get. So this is based on sample size. Okay, so we're not going to go into how it's doing this, but this is based on sample size. So you can see that the data of those follow a pretty much a linear trend when I compare the expected z-score to the data. So what this tells me is the following. The interpretation of this would be, the normal probability plot suggests the data comes from an approximately normal distribution. And I say approximately because really no data is really exactly normal. But when I say approximately normal, that is a code word for saying that it's so close that for practical purposes, assuming that it is. Okay. Now, I'm going to do one more thing here. In order to, in some cases, this is pretty easy to tell. In other cases, not so easy to tell. So what I like to do is concentrate between the data between -1 and 1. So again, this is pretty tightly bunched up, but I'm going to put a dot here and I'm going to come over here and try to just focus on the data between those sets. And then I'm going to sit here and I'm going to put a straight line through them as best as I can. So this, of course, I'm just eyeballing this. And I can see, again, should have been a little more careful, but oh well. So I'm going to try and draw this so it's definitely parallel to the other red line. And I can see again the data, it just seems to fall right around the line. It's not going to be perfect. None of us can, but yes, indeed, I can see that it does. The reason I do this is because the data in between -1 and 1, no matter what, is typically pretty straight. So what I'm looking at in reality is everything outside one standard deviation on either side of the mean. So again, when I look at these values, they're pretty much on the ball. And I look at these values, again, seemingly around the line and a little deviation towards the ends. Well, it's going to happen. What I'm looking for is a pattern away when it starts to build up. But I don't see that here. I see one went up, one back down, one back up. Again, nothing here to suggest that it doesn't come from a distribution that is normal. So what about this one? How much oil wells in a given field ultimately produce this key information in deciding whether to drill more wells. Here's in the Devonian Richmond area. So you can tell that, first of all, this is not symmetric, right? This definitely looks like it's right skewed as far as the distribution. And I mean, clearly these are probably outliers. I mean, yes, there's enough outlier, and probably these are outliers as well. And when I draw the normal probability plot, I mean, I clearly see that this is there's curvature. This is not straight. But again, just to show you how I do it, I would go between -1 and 1, somewhere in here, and try to draw, as best I can, a straight line. So I'm going to choose a little plot here, and then I'm going to try my best to try and draw a straight line. I didn't angle this very well. Oh well. I wish I could let go and redo it. I can't move this thing once. Yeah, it doesn't let me. Let me try one more time. Yeah, keep blowing that first one. Anyway, what I'm looking at here now is the movement away. And I can see here that if I follow the straight line, these values are moving away and there's a pattern of movement away. And down here, again, I drew this not good, but clearly this also is a pattern away from that straight line. So this is the kind of thing you would see. The middle, again, is always semi-straight. It's the ends that are the telltale sign. All right, so how do we create these plots? Well, you can do so in GeoGebra. So I'm going to go click here in GeoGebra Classic. And I'm going to need the spreadsheet. Okay. This I don't need, but it's not easy to get rid of right now. So if you want to get rid of this other plot, which I don't need, I'm going to go here to View, do the hamburger view, and get rid of this graphics part. Okay, so that's perfect. Now the graphics part is removed. Fantastic. Of course, I need the data. So how am I going to get the data? Well, I'm going to go to my Open Math, and in the week where we have this normal distribution stuff, there should be this file. This is not going to look like this in your term because it's for another term. Anyway, I'm going to click on here. Yep, I'm going to resume here. Okay, so this is our instructions on how this can work. If you can't do what I'm about to do right now, and this is going to be sometimes a little temperamental, but I should be able to come over here and highlight the data, then right-click, copy, then go to the GeoGebra spreadsheet and paste it. Let's see if it works. It's not going to do it, so this might be a good thing. Okay, so the thing that sometimes happens, and it gets these kind of strange codes. So here's what I'm going to do. I'm going to do this again. I'm going to close this and reopen it. Okay, so what I did was just did it again. I closed this instance of GeoGebra and then create another one. So one more time, I'm going to see if I can do this. It works sometimes it doesn't. I haven't figured out why it does this. So highlight it, come over here, click, paste it, and again it's going to do it. It wasn't doing it a minute ago. Okay, I'm going to stop the video and get rid of this. Okay, so you can see same thing happened. So here's another. Should all else fail, I'm going to download this file to somewhere. Okay, so I'm going to download it to my computer. So I'm going to download my to the downloads. So file, okay, data, great. Then I'm going to come over here, and I'm really going to, just to be careful, I'm going to just start over again. So I'm going to close this out and redo it. Okay, so I created a new instance, clean one. I'm going to click on the hamburger, and where's this file? I'm going to go to, let's see, I'm going to go edit. Okay, copy paste options, file. Okay, I'm going to click on file. There we go. And I'm going to click on open, down local file. Then I got to find where I downloaded to. I click on downloads. Gotta find that file now. Oh boy. I'm going to stop here first. Let's try this again. So I'm going to click here on the hamburger, open, local file. And right now notice the file has, it says GGB, which means that it wants it in the, this is the language, that GeoGebra, but of course you're not going to find it here. So what I want to do is click on all files, and then it appears right here. But the data has been saved in this very neutral format. That's not in an Excel file, but in its most basic form. So if I click on it, I just click on that, it says Excel. Now notice I went all files to see this file appear. Hit open, and the file, the data will appear all of a sudden. It didn't do it because it's already here. Okay, now I can do that. I'm going to highlight all the data. Can't remember if I'm not going to include the title here. And click the histogram button. Nothing seems to be working for me at the moment. Help. Nope. Should be fine. Okay. There we go. I click this again now. It won't. So it might fight you a little bit. Okay. So there is my histogram, which of course is sitting right here, but I want this normal probability plot, so choose normal quantile plot. And there's the file. Okay. All right, let's do it one more time. I'm going to come back over here to my open math, got that one. I'm going to go to question 2. There's the oil production data. Let's see if I can highlight it, see if I can get this to work. If not, I'll have to download it again. Copy. Paste. Come on. Nope, it's not going to work. It usually will do it right away if it's going to work. So I'm not quite sure why it's not. So again, I'm just going to download the data again. Call this data 2. Save it. Then come up here to open. Local file. And I'm saving everything in downloads. I gotta find my downloads, and then I gotta find all files. Then there it is. Okay, and there it is. It's now placed in position. And I think I already did it because it probably adjusted itself. Did it? No, it didn't. Okay, so let's do this one more time now. Go over here, highlight all the data. I gotta make sure that I'm highlighting it all. Sometimes I like to start at the bottom and then work my way up. Then I know that I've captured all of it. Okay, now I'm gonna wait here patiently. Don't know why it's so tricky today. Okay. So keep hitting this little button here. Yep. Go back. Did it do anything? No. Okay, hang on for a second. Okay. So I redid it again. I don't want you to struggle, but it's been a struggle. I like the version you can download and keep inside your computer. But again, it doesn't work good if you have an Apple product. Sometimes you have to kind of remove some of the safety features that Apple has installed on a computer. On a PC, it doesn't really matter. So again, I downloaded the data and then uploaded it and selected this button. But there's the graph. Okay. And you can see again that's how I'm creating this graph. We'll do just a couple more times. Okay, I'm going to go back to my open math. I'm going to go to question 3. And there's this set right here. I'm going to try in vain to see if I can make this work. Okay, I'm going to just right click and I'm going to do it on my keyboard instead of doing this paste thing. Maybe it works better if I use the control paste thing. Control V on my computer. Yeah, look, I did that. Really nice. So I'm wondering if the paste thing is just the thing that's not working. So all I did was click here and then hit Control V on my PC. I'm not quite sure what it is on an Apple. Once I do that, I'm going to click on this and again, click it a couple times. There we go. So I made this work right now by double tapping and double clicking. And I get this curve right here. I can see it's kind of a mess. But again, what I want to do is sort of try and imagine a line between -1 and 1, which is hard to do right now the way this is situated. What the computer is doing is doing a best line of fit throughout the whole data, but again, I feel that that's really hard to interpret. One more time. There we go. Once I do that, I can come over here, grab it. So I'm doing it again on my PC. It's the function key and finding the print screen button. Paste this. There it is. And then I'm going to just mark where -1 and 1 are. So here, roughly, I can look at the data. There's nothing here. We're on -1. And 1 is about right here. So I'm trying to find the best line through the data. Just about right there, maybe. Okay. Then I'm going to go here and draw between those two lines. It's a 36-degree angle. Okay. That's not too bad. Again, I want to get the middle, so I'm focusing on the middle here. I should have probably gone a little bit down. But if I do that, I can see that these points are pretty close to the line. There is a little bit of lift here, which worries me. But it's only one data value, so I'm wondering if that's a pattern or not. Again, hard to tell. Again, if I would have gone through that point, then this line would have been right here, and it would have been so off. Wonder if we do it again, but a different color. So it's mark it. Again, the problem is trying to get this to work here. Let's see. That's not too bad. Then let's try to extend to the best of my ability. It's not very choppy. I'm not sure if I did that right. But again, I see these 2 points are starting to lift, but this is only a point. I'm sort of torn, right? So right now I'm going to give this my blessings. Yeah, it's plausible that it comes from a distribution that is normal. Okay. Again, the issue here is there's not a lot of data values. So I'm going to go back to my open math, look at the next question. And again, by the way, this does come from a normal distribution. So I'm going to highlight this. I'm going to see if I'm going to copy it. Then I'm going to come back to the spreadsheet. And I'm going to click up here, but this time I'm going to get Control V. Yeah, so it looks like the pasting thing here doesn't like that right click and pasting. So I'm using the pasting, and now it seems to work just fine. Interesting. So I'm going to go from the bottom up, so I'm making sure I'm not leaving any data behind. Click here, and then again, it always does this. I'm going to double click, and then when I double click is when it does create the picture. And again, because there's so many more data values, you can see now that this is definitely following a straight line. I mean, there's always notice a little deviation at the end, but that's to be expected. And you notice it's a little wiggly, but that's fine because that's what you expect with real data. It's that wiggliness around the line, but it is following a straight line. But again, this does come from a normal distribution, exactly. So we'll do one more here. Copy this, go to the spreadsheet, see if we can do this. I'm going to click here and then Control V on my lap. Yeah, again, it does it nicely when I do that. So I'm going to highlight it again. Notice if I try to go from the top to the bottom, it doesn't work very good. It doesn't scroll. So I'm going to go from the bottom to the top. Then I'm going to double click on this. Boom, and it changed. And again, does this come from a normal distribution? Well, let me copy and paste this thing. So I'm going to hit the print screen so I can copy this. I'm going to hit the paste button here, see what it does. Yep, there it is. One more time, let's see if I can do it. Let's see if I can just eyeball it. Okay, because I'm trying to go between -1 and 1. I mean, you can see that it's definitely not looking good. So there it is. So I'm going to kind of find a line of best fit through all of this data. The middle data, though, is what I'm targeting as best as I can. The middle data. Okay, I feel like that a little better. That looks better. So again, I'm trying to. Oh, I moved it. Dang it! Jeez. All right. So didn't let go of my mouse in time. I can't do anything about that. Okay, one more time. I went through all this trouble, right? I should change color, but I can't now. Yeah, it's not going to change color. But again, what I'm looking at here is I try to fit all this. Maybe I should have gone a little further down now that I'm realizing. Oh god, it's getting too hard. But again, I'm seeing that definitely there's a movement. I think if I had done a better job here, let's see if I could fit through this. So much easier with a pencil and paper and a ruler. You can move around, but this is so hard. Okay, I like that blue line better. But again, I'm seeing just movement away, movement away, movement away. So it's this pattern that's going on either end that's really bothering me, and it's movement away. So again, I'm going to say that this does not come from a distribution that is normally distributed. If I did a histogram of this, just change it, what would it look like? Here's what the data looks like in a histogram form. And again, it's kind of quirky. So the whole idea is that, you know, this definitely does depend a little bit on how I make the widths. But yeah, clearly no matter what I'm doing here, it's not looking good. It just doesn't look like it's that symmetric shape. And this is also lending to that fact that they have this weird curviness that shouldn't be happening all over the place. Anyway, so what this suggests is that this data does not come from a normal distribution.